Day 819 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3016, minimum number of pushes to type word 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a string word containing lowercase English letters. Telephone keypads have keys mapped with distinct collections of lowercase English letters which can be used to form words by pushing them. For example, the key 2 is mapped with A, B, C. We need to push the key 1 time to type A, 2 times to type B, and 3 times to type C. It is allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type word after remapping keys. An example mapping of letters to keys on a telephone keypad is given below. Note that 1 asterisk and pound sign and 0 do not map to any letters. So this is just an example of a keypad. See right here, to type A, we press 2 once. To type B, we press 2 twice. To type C, we press 2 3 times. Same over here. To press D, we press 3 once. To press E, we press 3 2 times. To press F, we press 3 3 times, and so on and so on. So now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult. Now, first thing I want to point out, you'll see that these numbers or these letters are not the same as the letters on a real telephone keypad, right? This is a real telephone keypad. This is the keypad after we remapped them, because remember it says we're allowed to remap the keys number 2 to 9 to distinct collection of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to one key. So in this case, you can see that the letters are mapped differently than they are on a real keypad. So just wanted to point that out. Now, in example 1, we have an input word equals a string A, B, C, D, E. Output is 5, right? Now notice how the words are remapped. Or excuse me, how the letters are remapped. So to get A, we only have to press 2 once, right? Boom. So that's 1 press. To get B, we only have to press 3 once. Boom. To get C, we press 4 once. To press D, we press 5 once, and to get E, we press 6 once. Boom. So as you can see, each starting letter is on a different key. So we have A here on 2, B here on 3, C here on 4, D on 5, E on 6. Whereas so we could get all those letters in 6 and 5 pushes. Whereas opposed up here, just to get A, B, C, we'd have to push 1 push for A, 2 pushes for B, so we're already at 3 pushes, and 3 pushes for C. So we'd have 6 pushes if we had it mapped this way, just to get the A, B, C, not alone to get the D, E. We'd already be past 5 with the 6 pushes. So that's just an importance of why mapping. That's just an example of why mapping is important. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input word equals a string XYZ, 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 XYZ. The output is 12. It says the remap keypad given in the image provides the minimum cost. So X, 1 push on key 2. Boom. Then Y, 1 push on key 3. Boom. And then Z, 1 push on key 4. Boom. Then the total cost is 1 times 4, 1 times 4, 1 times 4. Add them, or plus 1 times 4. Add them all together. We get 12 because we need to type each key 4 times, right? We have XYZ once, twice, 3 times, 4 times. So we have to do 1 push 4 times for each of these characters, and in total it'll be 12. It says it can be shown that no other mapping can provide a lower cost. Note that the key 9 is not mapped to any letter. It is not necessary to map letters to every key, but to map all the letters. So boom, y'all. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, the first thing we're going to do is we're going to convert the string into an array of UTF-8 character values. So we're going to say let W colon square bracket int 8 come outside of that. We're going to set that equal to word dot UTF 8 C string dot drop last. Boom, just like that. Now we need to store the frequency of each ASCII character. So we'll declare a variable called counts, say colon, it's be an array of integers, and we are going to initialize it with a blank array. Boom. Now we're going to get the ASCII value of the character Z. So we're going to say let Z equal quotation mark Z. Come outside of that, we're going to say dot UTF-8 C string dot drop last. Put the parentheses dot first, put the exclamation point. Boom. Then we're going to initialize the frequency array with one slot for every ASCII value. So we're going to say for underscore n0 dot 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 z. We're going to open up the bracket, say counts dot append, open up the parentheses, pass in 0. Now we're going to count how many times each character appears. Since lowercase letters are represented by the ASCII values, each character's ASCII value is used directly as the array index. So come right here, say for CH and W, we're going to open up the brackets and we'll say counts, square bracket INT, open up the parentheses, CH, come outside of that, equals counts, square bracket INT, open up the parentheses, CH, come outside of that, plus 1. Boom. Now we're going to sort the frequencies in ascending order so we can later iterate from the largest to smallest. So we'll come underneath this, say counts dot sort. Boom. Now the first 8 most frequent letters require one button press. So we'll say declare a variable called ones, set that equal to 8. Boom. The next 8 most frequent letters require 2 button press. So we'll declare a variable called twos, set that equal to 8. Then the next 8 most frequent letters require 3 button presses. So we'll declare a variable called threes, set that equal to 8 as well. Now we're going to store the minimum total number of button presses. So we need a variable called result. We'll set that equal to 0. Boom. And we're going to process character frequencies from highest to lowest. So we're going to say for C and counts dot reverse. We're going to open up the brackets and we're going to assign the next most frequent character to a 1 press position if 1 is available. So we'll say if ones is greater than 0, we'll open up the brackets and we'll say result plus equals C times 2. Boom. Then we'll say ones minus equals 1. Boom. Otherwise, we're going to assign it to a 2 press position. So we'll come right here and we'll say else if 2's greater than 0. We'll open up the brackets and we'll say result plus equals C times 2. 2's minus equals 1. Boom. Otherwise, we're going to assign it to the 3 press position. So we'll come right here and say else if 3's is greater than 0. We're going to open up the bracket. We're going to say result plus equals C times 3. Come underneath that, say 3's minus equals 1. And any remaining characters require 4 button presses. So we can just say else, open up the bracket, result plus equals C times 4. And then finally, we need to return the minimum total cost or the minimum total number of presses needed to type the entire word by coming right here, and we could just say return results, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly, which it does not. Oh, sorry, y'all. So that should be in W, not in 2. So let's switch that. Run it again. See if that fixed it. Okay, cannot find count. So let's add this S. Oops. Let's add this S and run it again. You have got to be kidding me. Let's put this S right here and run it again. Fingers crossed. Wrong answer. So you know what that means. When we get the wrong answer, that means somewhere along the line the math is not correct. So give me a moment while I check these numbers. Let's see, so we could see. Oh, so this right here should not be C times 2. It should just be C. So now let's try that and see if that fixed it. Let's see, it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Boom, and look at that, y'all. 31 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.